Hi, this is from Dr. B. Vijaykumar, HOD of Physics, Department of Physics, SNS College of Engineering. Today we discuss the Unit 4 Crystal Physics. The topic is Miller indices, interplanar distance. Then the thinking question in my student I am asked from that to starting of this video. How do you find the Miller indices of a plan? Then why do we use Miller indices? How do you calculate lattice spacing? Then Miller indices is a form of notation system in crystallographic for planes in a crystal lattice. A family of lattice plane is determined by three integers h, k and l. The Miller indices is formed in that. The cubical crystals, the lattice constant is a, because all the sides are equal, so we form in the lattice constant is in a. The spacing distance is d between adjacent HKL lattice plane it form. So d HKL equal to a divided by root of h squared plus k squared plus l squared. So this is a diagram of Miller indices to in a different values of HKL planes, intercepts. So the 1 0 0, that means the x is in a 1, the y equal to 0 and z is 0. So the a1 only to be act in that, so that color pink color is formed in the a1. So this is become 1 0 0. The second yellow one 0 1 0, so the only a2 side. Then another one is in a 0 0 1, that is in a a3 side. So this is very simple because it's only one axis to be acted in the intercepts. Next one is in a 1 1 0, that means x, y, z. Then a1, a2 is interconnection, so it start from diagonals. The similar in 1 0 1 and 0 1 1. The next one, inverse 1 1 0. It's a form of another one. It's not a form of a. So it's connected in a A3 and A2. It's similar in other types of inverse also. So this picture is very important to identify of Miller indices in a different value of HK and L. Then I give the assignment from my student to finding of that the value of this picture. Then we start from interplanar distance. So the interplanar distance, which is a separation between set of parallel planes formed by the individual cells in a lattice structure, depends on the radii of the atoms forming the structure as well as on the shape of the structure. So we take a one triangle cubical structure to the form of three coordinate axes x, y and z. It forms some intercept, it get one triangle of ABC. The corner is O, its starting point. So we draw the normal lines at O, we get in ON. So it becomes the centroid of the cube triangle ABC. So we get some angle also, alpha, beta and gamma based on the coordinate axis. So finally we get that the formula D equal to A by root of h squared plus k squared plus l squared. The HKL is in a Miller indices and A is in a lattice constant. So this mathematical steps we get from that the formula. So the cos alpha, cos beta and cos gamma, cos value is an opposite by hypothesis. So we get the triangle based on OM by OA equal to D2 by 2A by H. So the D2H by 2A. Then cos beta OM by OB, cos gamma OM by OC. So this all we get from the same, the only to be change of H, K, L, it based on the angle of alpha, beta and gamma. So this is a mathematical formula, cos alpha, the ratio of cos beta, the ratio of cos gamma. So the D2H by 2K, D2K by 2K, D2L by 2K. So we substituting this value is equal to 1. So the common term we taken it, then d2 squared equal to 2a 4a by L squared plus k squared by L h squared plus k squared plus L squared. So the finally we get in that value of d equal to 2a by root of h squared plus k squared plus L squared. So we have find from the interplanar distance. D is an interplanar distance. So this all the reference I prepare the PPT of Miller indices interplanar distance of the crystal physics. Thank you very much. We discussed in another one video in another one topic. Thank you.